Morning, everyone. So nice to have you all here engaging with us. And I think we've made a transition now from all the startup investment and entrepreneurial segment to how you can really harness the power of technology and how it's going to really help you grow and go in your journey forward. And I'm very honored to be here with Ajeya, a friend I've known for many years back, and it's been interesting. We shared a platform similar a few years back, and we are here again. So nice. Thank you, Ajeya. Let's start with this, right? In the previous segment, there was a lot of talk about robotics, machines, and how information is going to be used to have these machines act. Just to get you all energized, what do you think is very key for all of them to operate, act, or take a decision? That's right, it's data, right? So this is the section we are in. So data is so much underpinning for making any predictive analysis, for taking any of those decisions. And at the same time, I think all of us over here are probably generating a lot of data as we speak. In fact, I was reading reports that on a daily basis, quintillion bytes of data gets actually generated. And then we are trying to form insights out of it. In fact, in our enterprise at S&P Global, we are generating essential intelligence and insights from data that we gather from financial sectors, commodities, the automotive mobility sector, so that our clients can benefit and take their actions. So data is very key, and I think what we should always be prepared for is it's growing like at an unprecedented level. Fivefolds just over the last few years, thanks to the previous session, IoT and the robots creating additional data to act on. So Ajeya, as we learn about the growth of data, right, how do you think enterprises, or what should be their strategy to actually handle this data growth? Because everyone is now jumping on to the AI strategy even more, and with the advent of Gen AI, and data is key. So how do you think they can really plan for a data storage strategy? And second thing is, as we spoke about the large amount of data growth, right? People start thinking about performance. They think about cost efficiency. How can we get this all like a package?
Yeah, it's a great question, but before that, it's a pleasure to be here at NASScom and to be talking to you, Sugandha. So happy to be here, and good morning, everybody. Yes, last panel, Satish's panel, I think, as I was seeing all of those robots and what they were talking about machines, a little bit of my experience before I answer this question. So when I was in San Francisco last month, it was like, it was very easy for me to call a Waymo cab and go around with it. If somebody doesn't know what a Waymo is, it's a completely self-driven car. It's a Google venture, and it was so convenient. So that was like a standard way for me to commute. And the only question I had in my mind every time is, how fast are these inferencing models, right? So how are you making these decisions? So the way the car runs is essentially, it drives in a very aggressive manner compared to a regular US driver, because it's got much better cameras and it can see much further off than a human eye can see. So it will easily calculate how far the car behind you is and whether it can cut through a lane, right? And once it cuts through a lane, like whether it should slow down or speed up depending on whether there is a pedestrian that's actually waiting to cross or not. How do you make a left turn? So it's a super intelligent car. So what I'm trying to say is, the amount of data that they may have used for training something like that and making that available on premises, which means in that case it's available on the car, I mean, that's just a phenomenal amount of data. And to answer your question, some of the tenets that you got to use here is, firstly, it's performance, because you need super fast access to data. Secondly, it's density. You can't really have a data center attached to your vehicle when you're going around. So it has to be like a very portable device. Thirdly, I think it needs to be very scalable. So the architectures that we think of has to be such that they are extremely scalable and scale out in nature, right? I think these are like three tenets that you usually think of in context of any modern data pipeline that you have to attach to a modern GPU front end, right? Again, there are lots of things, right? Like, for example, data bloat. That's very common in AI, right? Like, how do you actually quickly reference this, and how do you actually figure out, like, how do you figure out that this embedding actually refers to an answer that is sitting somewhere there in this multi-dimensional vector space, right? Like if you imagine, let's say, 1,000 characters, and let's say they're all ASCII characters, right? And for simplicity's sake, it's 1 kilobyte of data, right? And let's say that this is something that you need to actually draw inferencing from. So essentially, let's say that we use that in a vector space. And let's say it's a 678 dimensional vector, right? So assuming that you're actually using a 32-bit floating point for each of them, so you're really looking at a 3x data bloat at about 3 times. That becomes like 3 KB. And then you have to do indexing, so that becomes like at least 3 more times, so 3 into 3, that's 9, right? So you're really looking at 1:10 data bloat when you're actually using it for AI. So that's why density becomes extremely important, that you need to provide for that density there. So any system that can provide these 3 things that I spoke about in terms of scale, performance, and density, I think you will definitely win in this space.
Great. No, thank you. The title of this session says the data supply chain, right? And we all know that unless there is a data collection process starting in place, there's nothing really happening in the pipeline. So can you share how the entire storage strategy works when you're looking at a data supply chain? And secondly, there is a very great importance around data security. We are all seeing all the news and information around how we need to now safeguard our data. In fact, what I'm really liking is the measures from many of the Indian banks and even the RBI, where they are talking to regular citizens, teaching them how they can safeguard, right? So, but when we take it to the back end, how can you really bring in the whole facet of data security when you're talking about data storage? So how do you do data supply chain and the cybersecurity aspect?
No, this is an excellent question. So let me talk about the supply chain first. Usually, if you look at RAG models, or if you look at, let's not even talk about GPT, right? Let's talk about retrieval augmented generation. What usually happens is that your data sources that you actually encode are going to be across thousands of databases spread across the world, right? And then you have unstructured data, which is even more ubiquitously available, and it's spread across everywhere else. You actually have a way, you should have a way to actually bring that in one place and curate it so that you actually run that. Right? That's the key part of that supply chain. There's another element of complexity to it. How companies usually try to tackle that is they have all of the data everywhere because they want to optimize for latency. You really don't want your inferencing to be taking more than a couple of seconds. In fact, ideally it has to be in milliseconds, right? So that's why they try to get everything everywhere. And given the gravity of data, in the sense that the amount of volume that you need to actually transport from one place to the other, it's highly unlikely that you will be able to achieve that in a cost-effective manner. So some tactics there is effective use of metadata. What if you are able to present the attributes of data, which is only a fraction of the size of data, and make that available in all your data centers across the globe? Let your models decide, or let your training algorithms decide what they need and pull that as they want to do that. So that's a way in which you can achieve maximum compression in terms of your footprint of data. So that's one of the key aspects of supply chain. Coming towards security, actually there are several tactics, right? I think there are a lot of tactics you apply in the front end. You have ransomware detection. You actually identify patterns. You actually identify understanding of, are there logins happening from different places under the same name? And it's really not possible. But outside of that, there are also similarity-based comparisons that you can do at a lower layer, right? Like, for example, use AI. It'll tell you if it's actually observing a pattern in the manner in which your files are getting encrypted very, very quickly. So you understand there is a ransomware activity that's actually happening. By the time your front end actually figures it out, you will have your back end already understanding something is happening, and it'll put a stop to that. The second one is, of course, there are levels of self-encryption that you use, but then there is also this problem of keys that actually goes away. I have met several interesting startups that are kind of quantum ready and using quantum keys. I mean, I've been fortunate to work with one of them, where you are actually kind of ready for the future when there is a quantum computer that's actually ready and trying to hack into it. you have a quantum key that it can actually not hack, right? So things of that sort. So there are several things that we can do at the data layer which are much more efficient in actually tackling some of that and really stop intrusion in the data path.
Got it. You sort of alluded to using AI, right, as you're looking at the whole data storage and retrieval. But when we look at AI, many of us already made the transition to cloud, but we are now seeing a lot of on-prem stacks coming up, right? So how do you think, or how can one envision an on-prem strategy with respect to, say, storage when it comes to generative AI or the LLM models? And why should they even think about it?
No, this is a fantastic question because I think as we progressed and we leapfrogged a couple of cycles, I think a lot of enterprises, especially in India, have a lot of their data in the cloud. Now, like what happens, right? So if you have to train your models or if you have to inference, the operation that actually happens on the data is reads. There's phenomenal amount of reads that actually happen. How do your cloud providers charge you? They charge you per read. So you're actually going to be spending maximum amount of money doing the core thing that you want to do, which is why actually you're finding a lot of people having this data on-prem, right? So I think that's core to that strategy. Again, as I said, in generative AI, you need to have powerful data structures that give you extremely fast similarity-based inferencing. For example, I spoke about the vector database.
Yep.
And that inherently today provides phenomenal bloat, a 10x bloat. And imagine having the 10x bloat in the cloud and you're actually reading that and you're actually referencing that. It becomes extremely unsustainable at that point in time.
Got it. And while you're talking about this, right, if you want to add a bit about how pure storage is actually helping, something to share. You were talking to me about it a few days back.
No, actually, I think a few things. Pure by itself, we do what we call as flash storage. And when I say flash, I'm not really talking about SSDs. In the sense, SSDs is a storage that's there in your phones, is there in your laptops, right? And it's anybody that claims to be a flash storage company uses only SSDs. SSD is a solid state drive, which actually is a wrapper on top of pure flash or NAND, right? So this is written by using additional memory so that it can convert your application calls that are actually built for disk to flash and then convert the outputs from flash to disk. What we do is we've directly tried to build on NAND, which is a pure form of storage, by which we eliminate we are at least 5 times more energy efficient than our competing all-flash companies because we don't have these additional layers on top of our flash. So our software stack is built on that. We've tried to pack 4 bits of data in a single cell. So we call that as QLC NAND. That's our technology. So we try to kind of optimize from that perspective. Secondly, we have what you call as zero-move tiering and technologies as such where tiering is a big thing, right? So you want to tier your data from an expensive tier to a less expensive tier. It takes really days and weeks and months if you actually do that. So we figured out a way to kind of do that almost instantaneously based on subscription with the device on premises that will make it available for you. So you can quickly move between data that's hot and cold. You need hot data for building your models. You need hot data for inferencing. All your other data, you can actually keep it in your code.
Got it. I think this actually kind of segues to our last question. I love this short session formats because I think you can pack in a lot of learning and then follow up. You mentioned about energy saving, right? I think it's on everybody's mind. In every panel that happened earlier today, there was a reference or a question which spoke about sustainability when you're thinking of innovation, when you're thinking of implementing, and sustainability for AI, generative AI. So how does this all come in place when you look at data storage?
Interesting. So one of the key things is like forget about storage. Even if you forget about any particular like everybody thinks about AI, you're thinking really about GPUs, right? And depending on where you read, about 1 to 3% of world's energy is being used by data centers, right? And we are the biggest offenders there, actually. So from a carbon footprint, that actually accounts to 5% of world's carbon footprint, right? So this is, and you just spoke about it, Sugandha, you were talking about how data is growing, like it grew 5 times in the last year, right? So that's not going anywhere, right?
Yeah.
Like kids at home are actually generating AI-generated images and sharing across and creating multiple copies, so that's just growing. So you need more and more data centers. So our strategy is, how can you think of actually compressing that, right? We do it in a couple of ways. One is through a footprint compression, which means we increase density. The same drives that hold 75 terabytes of data today will hold 150 by end of this year. It will hold 350 next year, and it will hold 600 the year after that, right? So it's the same form factor. So what that does, you're doubling your capacity to hold data with the same form factor, with the same energy. So you're actually saving a lot of it. If you look at any rack today, I think you're taking somewhere between 10 to 15 kilowatts of energy to actually run that. Really, I mean, the GPUs themselves need close to 10 kilowatts. So how do you operate in that smaller footprint where you are actually providing more data storage at the same thing? So that's been our strategy. Our strategy is to do more density for same power and continue that journey.
Great, nice. I was told that even this badge has a whole sustainability aspect. In fact, it's written here. So this is amazing, right? The feel is actually good.
Yeah, that feel is very good. In fact, I had somebody tell me that, yeah, this looks really good.
And it will grow. That's what it says over
Yeah.
here. That's nice. So yeah, we are at the end of our chit chat on how data as a supply chain is underpinning and helpful for a lot of the AIPs. I think we have room for 1 or 2 questions at max. Anyone has a question? I see
Is
one.
someone back there?
Yeah, I see one here, one here, and one here. Yeah.
Hi. Can I ask the question? Yeah.
Go ahead, please. Sorry,
Yeah,
I didn't see you. Yeah.
Thanks for the session and hope you are doing well. I'm Nitin. So I have a couple of questions. So you spoke about on-prem, like cloud coming back on-prem. So there are multiple reasons to it, like latency issues or security issues on cloud. So how do you see edge fitting in that whole scenario, edge computing fitting in that on-prem scenario? And again, how do you see edge computing fitting in the inferencing scenario? That is one. Second is, how do you see GPU as a service? Because GPU are it's like a mineral which is like short in nature. Then how do you see GPU as a service becoming the next big thing?
Yeah, I can take this, maybe if you want to chime in later. Yeah, first of all, I did not say there's a security concern in the cloud. I think cloud has taken care of it, and I completely trust it.
Sure.
I think repatriation of some data on-prem is primarily because you want to get over the problem of expensive reads and latency. These are two things. And that is happening in targeted cases. Of course, there are advantages of the cloud because you don't really need to define like hard data structures. There is somebody else that is taking care of your pipeline, right? Like if you were a developer, like you know that you want to actually execute a build in the next 1 hour, right? And you want to make sure that all of your environment is updated all the time. You don't have the time to set it up. So there are like N advantages of the cloud. But I think for that, cloud will always be relevant, and I'm a huge supporter. I think but there are some things where you have reads in enormous data sets. I think those are the cases where it's better to have it on-prem because you're not bleeding as much. That is one question. And second question with you in terms of how, part B of your first question in terms of what is the future of edge. I think edge is where you derive all your intelligence, right? Like I started off talking about the Waymo autonomous car, or you also saw Elon Musk launch the robocar. I mean, there are a lot that is edge for you, right?
Yeah.
So all of those on-the-spot decisions are happening on the edge. And for that edge to work, you need to have your inferencing data available on the edge so that you can quickly understand what's going on and make a decision live. I think that is the future of edge. And because you don't want to kind of, network is getting better, you can actually send data back and forth, but there are sometimes you need to make split-second decisions that you want to do. So edge is edge is always going to be much better off having data on the edge. And I think, yeah, there is no alternative to that. Your second question was regarding
on
what?
the GPUs. So GPUs are like you have
Yeah.
short supply.
Yeah, it is. Yeah. So this, I believe, is already happening today in the cloud. I think one of the things that people actually effectively do, and I think I am personally a big supporter of that, is essentially you could have your GPUs in the cloud and you're renting that out. You need to have data co-located. It doesn't need to be in the cloud, but it can be in a data center. I mean, there are several companies, that actually do. I think there's Equinix. There's so many other companies that actually have your own data centers close to where your cloud data center is, so that there is very minimal latency between your data and the cloud. So that could be a great way to do that in terms of you're able to bring in data to actually take advantage of your rented out GPUs in the cloud and basically send it back once you have finished training, basically.
But this is on the cloud. Have you seen in the valley or somewhere happening that on the edge, on the premise, the GPU that is on the premise, having a software orchestration layer where can separate 2 or 3 modules or different modules for different parties?
I have seen that, but I have seen that more for ourselves. Like if I have a GPU farm for me at Pure, I am actually renting it out to various of my application teams to actually use that.
Got it.
So the orchestrator is very inbound right now, where we are actually using it within our. I have not, but once I rent it out to others, then this becomes the cloud by definition. You know what I'm saying?
Yeah.
Yeah.
Cloud by definition with low latency. So
Yeah, correct.
Sure.
Thank you.
Thank you.
I think we have to cut short
We
now,
have to?
but we
Okay.
will connect later because we are way over time now. But really engaging discussion. Thank you and thanks, Ajeya.
No,
but
thanks.
we are around and we will definitely love to connect back with a couple of you who had questions. Yeah.
Thank you
I'd
so
like
much.
to thank
It was a pleasure
the
talking.
panel for that discussion. Request.